Hello friends, myself R.D. Mahajan presenting my video on Z transform topic inverse Z transform by residue technique. In this video, I am going to discuss two simple problems how to find inverse Z transform using a residue technique. The first one, find inverse Z transform of Z square divided by Z minus 1 by 4 into Z minus 1 by 5. And to determine its inverse Z transform, let's consider f bar of z as z square divided by z minus 1 by 4 into z minus 1 by 5. There are two factors in the denominator, and equating each factor to 0, we get therefore z is equals to 1 by 4 and z is equals to 1 by 5 as two simple poles. And therefore, we require to find out residue at the first pole and residue at the second pole. Then multiplying this by z raised to n minus 1, we get z raised to n minus 1 into f bar of z as z raised to n minus 1 multiplied by z square divided by z minus 1 by 4 and z minus 1 by 5. Nothing but multiplying it or adding the power of z, we get z raised to n minus 1 plus 2, we get plus 1 and whole divided by z minus 1 by 4 and z minus 1 by 5. Then residue at the first pole by first formula, it is z minus e, z minus 1 by 4 multiplied by this term. That term is z raised to n plus 1 whole divided by z minus 1 by 4 into z minus 1 by 5. At z is equals to e is here 1 by 4. This z minus 1 by 4, z minus 1 by 4 get cancelled, and therefore we get remaining term as z raised to n plus 1 divided by z minus 1 by 5. Then substituting z as 1 by 4 here, we get 1 by 4 raised to n plus 1 whole divided by 1 by 4 minus 1 by 5. Splitting this as 1 by 4 raised to n and 1 by 4 raised to 1, nothing but 1 by 4 and whole divided by 5 minus 4, we get 1 and that is equal to 20 by 4. 20 by 4 we get as 5 into 1 by 4 raised to n, and we call this equation 1, the first residue. Similarly, we try to find out residue at the second pole. Then residue at z is equal to 1 by 5. Again applying the same formula. Therefore, z minus a, this time it is z minus 1 by 5 multiplied by this term. That term is z raised to n plus 1 and whole divided by z minus 1 by 4 into z minus 1 by 5 at z is equals to 1 by 5. This time z minus 1 by 5, z minus 1 by 5 get cancelled. We have substituting z as 1 by 5, we get 1 by 5 raised to n plus 1 whole divided by 1 by 5 minus 1 by 4. and therefore it is equals to 1 by 5 raised to n, and 1 by 5 raised to 1 nothing but 1 by 5, and whole divided by 4 minus 5, we get minus 1 by 20, and therefore minus 20 by 5, 4 times 1 by 5 raised to n, and we call this equation 2. Then taking the sum of these two residues to get the value of that inverse Z transform. Therefore that inverse Z transform, that is f of n, is sum of the residues. The first one is 5, 1 by 4 raised to n, minus 4, 1 by 5 raised to n is the required answer. Or that is the value of that inverse Z transform obtained by a residue technique. One more problem. Second example, find inverse Z transform of Z divided by Z minus 1 bracket square. And therefore, let f bar of Z as Z upon Z minus 1 whole square. In denominator, we have one term, that is Z minus 1. Equating it to 0, we get Z is equals to 1. It is a pole of order 2. Pole of order 2. This is the value of m. This is not a simple pole, as the power is 2 here. Therefore, it becomes a pole of order 2. And as it is a pole of order m, we have to apply second formula. And therefore, before that, multiplying it by Z raised to n minus 1 on both sides, we get Z raised to n minus 1 multiplied by Z divided by Z minus 1 whole square, that is equals to, adding the power, we get Z raised to n plus 1 minus 1 get cancelled, and divided by Z minus 1 whole square. Then a residue at the pole. Residue at Z is equals to 1. Using second formula, which I have discussed in my first video, 1 upon m minus 1 factorial, that is 2 minus 1 factorial, and same order derivative, that is d by dz, it is 2 minus 1 means 1. Therefore, first order derivative with respect to z of z minus a raised to m, here m is 2, therefore z minus 1 whole square, multiplied by this term z raised to n minus 1 into f bar of z, it is z raised to n divided by z minus 1 whole square. And at z is equals to a is here 1. And therefore, this z minus 1 square, z minus 1 whole square get cancelled. 2 minus 1 is 1, 1 factor is 1, therefore it is 1. D by dz of remaining term is here z raised to n, and after finding that derivative, put z is equals to 1. And therefore, differentiating it with respect to z, we get n z raised to n minus 1, and at z is equals to 1. And therefore, substituting the value of z as 1 here, we get that term as n 1 raised to n minus 1. 1 raised to anything is 1, and therefore the value is n value of f of n is n. For the condition n greater than or equals to 0. Therefore, the inverse Z transform of Z upon Z minus 1 whole square is n for n greater than or equal to 0. Then we cross check it whether we get the same Z transform for n. We know the value of Z transform of n as Z upon Z minus 1 whole square, which I have already discussed in my previous video. Some more I will discuss in my next part of the next video, that is part 3 for this inverse Z transform. Like my video, also share it and subscribe to my channel, and to receive the notification for my new videos, press the bell icon. Thank you. Thanks for watching.